Okay, so this is Geology, Chapter 3, Section 1 lecture. Okay, so first of all, here's the essential questions we're going to have to answer when we're done. A little bit of review vocabulary. This should actually, your new vocabulary should actually be a review also, but whatever. Just remember, as we start out, matter is anything that has volume, takes up space, has mass. Element is a substance that cannot be broken down into simpler substances. All right. And then it goes on to talk about gold, bricks, coins, statues. Just remember, we have a periodic table of the elements. An element is what you find on here, and those elements cannot be broken down into simpler substances. It's as small as it gets. Then we have atoms. Okay, atoms have protons, neutrons, and electrons, a nucleus. Okay, and let's take a look here. All right. So when we draw an atom, we put the protons and the neutrons in the nucleus. That's this center part right here, the nucleus. And then electrons cruise around out here, okay, in these orbits. Now remember, the big thing, you can only get 2 electrons in the first orbit. And then from there on out, 8. So it'd be 2, 8, 8, 8, 8, 8. So for example, if we look at oxygen. Oxygen on a periodic table is number 8. Oxygen is number 8. We would go like this. 8 protons, 8 neutrons, and then we're going to have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 electrons. This would be oxygen. Okay, oxygen. All right. So, whoops, didn't mean to do that. Let's move this around a little bit. And here we are with the periodic table of the elements. The electron symbols for the elements. Remember, each element has its own symbol. This should all be review again. Hydrogen, helium, and the rest in here. Okay. Those are your symbols. Each symbol stands for a specific element. Atomic number, atomic mass, all this can be found on the periodic table. Remember, your atomic mass is in AMUs, atomic mass units. The mass number can also be found on and you can look any interactive periodic table online is great. Here's your atomic number, your atomic mass, and your atomic mass is in atomic mass units, atomic number, and atomic mass units for the mass. Isotopes are atoms of the same element with different numbers of neutrons. Okay, different numbers of neutrons are isotopes. There are radioactive isotopes, isotopes that break down. Carbon-14 is a radioactive isotope of carbon. Electrons and energy levels, filling their energy levels. And again, you'll see here too, 1, 2, 3, 4, 5, 6. Did they use? Oh, they used oxygen. So, and then 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and then 3 on the outside. Just remember these energy levels, okay? Energy levels. Hopefully you learned that in chemistry if you took chemistry. All right, so valence electrons. Remember, an atom can have no more than 8 valence electrons. All right, and why is that? That might this might jog your memory on 8 valence electrons. If we can go to the periodic table, when we first got our periodic tables, when you were in my class or in physical science, hopefully you had me. If you didn't, you had somebody else, and I hope they showed this to you. If they didn't, I'm showing you right now. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this tells me how many valence electrons I have. Okay, and if you had me, you know the magic number is 8. They want 8 valence electrons. They all want 8 valence electrons except for hydrogen and helium. Helium only has 2 valence electrons, okay? And hydrogen has 1 valence electron. It only wants 2 because you can only get 2 in that first orbit, in that first energy level. So this is why, if you look at this, H2O, H2O, the magic number is 8. 6, oxygen is a 6. So we'll write that down. Oxygen is 6. Hydrogen is a 1. And there's 2 hydrogens. So 6 plus 1 plus 1. Again, 6, 1, 1 equals 8. That's our magic number. Okay. If I have, for example, if I have lithium bromide, lithium is a 1. Lithium is a 1. Bromide or bromine, Br. Br is a 7. 8. Okay, so this is how we come about our chemical formulas. They have to equal to 8 or some form of 8. Okay, 16, 24. When you add these numbers up, there'll be a multiple of 8. Okay. All right, so back to where we left off. Valence electrons, then ions. Ions have an electrical charge. All right, remember, let's go back to this. Remember that I have a staircase here. I know my staircase don't look that good, but here's my staircase. All right. So these gain electrons over here. They're going to gain electrons. Everything over here likes to lose electrons. Lose electrons. So hydrogen, when I lose an electron, hydrogen ends up being, see if we can go down here. Here we go. Hydrogen will be a 1 plus. Sodium is in that same, it's a 1 plus. Potassium's there, that's a 1 plus. Okay, everything here will be a 1 plus ion. In this row, it's going to lose 2 electrons. So beryllium is a 2 plus, as is every other element in this family. Magnesium, calcium. We can put those down too. Magnesium, 2 plus. Calcium, 2 plus. All right. Now, over here, where my staircase is, aluminum's going to be a 3 plus. Boron is a 3 minus. Okay. That's going to look like this because boron's on the left of the staircase. I'm sorry, the right of the staircase. It's going to lose or gain 3 electrons. Geez, oh, Pete. It'll have a 3 minus charge, where aluminum is on the left-hand side. It'll have a 3 positive charge. Okay. And that's the way this is going to work. That's what an ion is. It's it's an element or an atom with a charge. Okay. And then it asks you here which elements are most abundant. Easy enough. Here they are: oxygen, silicon, aluminum. And here's the most abundant in the universe and in Earth's crust, the most abundant elements. I hope this helped you with refreshing yourself with atoms and the periodic table.